everybody. Oh, sorry, it's in the end. Lovely. Wonderful start for me. Okay, I'm just going to show the title here and then go on to the presentation. So my presentation is on the data acquisition workflow to get a level of detailed tree geometry semi-automatically, and to also utilize point clouds for urban building energy modeling. So I'm not going to make a deep dive into decarbonization goals of Europe, but I will talk a little about the state of art for renovation projects currently in Estonia. So we often talk about how construction sector as a whole is lagging behind on digitalization. Well, in Estonia, for renovation, if we zoom in on renovation field specifically, well, it has barely made it to the starting line. If we look at the usual renovation project for residential building, they take the drawings from the archive, they digitalize the drawings, yes, and then they offset the perimeter of the external wall to indicate a line for where the insulation comes. And that's it. That's the level of digitalization there usually. But on a rare case where somebody decides that, yes, we need to have some simulations for energy performance, for an example, for building, usually when universities involved, then generally this is what they do. They basically take the building, they place it on sort of a field, so there are no surrounding buildings, there are no surrounding trees or anything. It's just the building by itself. And why is this a problem? Well, if we talk about renovation, then usually there is surroundings there and there are trees, and especially now that overheating is becoming a problem, something new for Estonia, right? Then we could actually benefit from the shading of the trees and the surroundings, especially when the goal is to go from a single, for planning is to go from single building level to a district level. So if we talk about district building level assessment, then usually we use a level of detail 2 models, which is great that we have them. But if we talk about overheating, then, well, we don't have the windows, so what are we going to even try to estimate? Usually for solar panel potential, it is enough, because generally we want to put them on roofs, and the roof shape is generally pretty detailed. But for a district, we usually have some goals if we want to evaluate the district potential. And for Estonia, typically, we can't get to that target if we only put solar panels on the roofs. So we would like to know what would the benefit of putting them on facades would be. But, well, if we look at just that, then there's great potential, right? So much open area, but, well, we know that there are windows and there are balconies there. And for incorporating the trees, for an example, then, well, the initiative is to get more green areas in cities. So I think the shading effects from trees and the greenery will become more prevalent in future years. So what did we do? We created this data workflow to integrate data from different sources to facilitate making a level of tree models for renovation projects, for assessment in early stages, because if they don't make detailed models when they are renovating a specific building, there is no chance that anybody is going to make it for early stage assessment reasons. And then we examined the benefits of the workflow through a solar exposure study. Why solar? Because it's the most simplified way to get an indication of what the effect would be. So why are we doing this now? It's not like trees are suddenly have grown. Well, for us, the stars have kind of aligned, so we have great data sources. We have had the Estonian building registry for a while now, but lately we have been doing a deep dive into the quality of data and the possibilities there are. Then we have this geometrical data. We have the point clouds covering the entirety of Estonia, and we also have a level of detail 2 models. And then finally we have made these quite detailed building archetypes So you can see different, there are just quite many archetypes on apartment buildings that allow us to have this data to know what kind of, how the geometry would be. So how did we do it? For geometry, we used Rhino 3D with Grasshopper to automate the processes. And for simulations, we used Climate Studio. And our general workflow was first we looked at data availability and sources, then how to gather this data, how to prepare it. Then we developed the workflow, and finally we did the solar exposure study. So for this, we chose a pilot area. This is a pilot area in Estonia, in the city of Tartu. There are 22 apartment buildings in the area. Out of these 22 apartment buildings, we actually have only 7 unique buildings if we look at the number of floors and the number of staircases. And if we look even more closely, we can see that actually those 7 unique buildings can be made up from only 2 different staircase models. So if we know the number of floors and we know the number of staircases, well, then all we need is the geometry for the 2 models, and we can just build up the buildings from there. So the first part of the workflow that we created was the data gathering and aggregation. Our main data source was a building registry where all this data is available. We collected the pilot area point clouds. Also, this design documentation is available there to make the templates, level of 2 geometry, and then finally general building data, building ID to connect the geometry and the data. Number of floors is also readily available there. Only thing missing is number of staircases, but we made a pattern recognition algorithm to get the number of staircases from there automatically based on apartment information. So then there is the point cloud processing, generation of LOD3 models, and then finally the solar study. So for the point clouds, we acquired them from building registry. We used cloud-based segmentation to categorize it into ground and other objects. And then from there, we categorized it even further into buildings and then trees. For the trees, well, we can't really use the point clouds themselves, so what we did is we voxelized them. We tried to strike a balance between having enough voxels so the tree shape was still recognizable, while having the voxels big enough so the computational cost wouldn't be too high. But this workflow is a bit outdated for us already, because now this year we have actually a database with actual tree shapes already existing in Estonia. So as you can see, there is these pretty realistic tree shapes and also simplicated tree shapes also, and they even have some data attached to them. So they have this, whether it's, for example, a hardwood tree or not, and also the height of the tree and the diameter of the tree. I added a QR code if anybody wants to explore that map. But the problem with this is currently it is already downloadable, yes, but the problem is if you want a single tree, or let's say a plot of trees, then you have to download the entire city and then manually extract that specific shapefile. So that's why currently we have taken the point cloud route, but hopefully in the future. So then the geometry templates. Well, we defined geometry templates as a 2D representation of a typical floor plan. We divided it into a set of lines and points which all had attached the category that shows their function or their position. So there was for us, as I said, 2 different models in the pilot area, middle module and the side module. And then the points indicate a window, so a window center point. And then we have the external walls, stairwell walls, and balconies as lines. On Rhino, it looks something like this. And then from this, knowing the number of staircases, we can create the actual floor plan of the building. Then we match these created floor plans to the LOD2 level geometry, rotate and fit it inside the existing geometry, and then basically copy it up in a number of the floors. So what we basically have is analytical model, and we created this so that this analytical model can be inserted into, let's say, Ladybug tools or other tools for simulation. So from this, we get this. So for our solar study, we created 4 scenarios, building on a field in level of detail 2, same thing but in a level of detail 3, then with other buildings, and then with trees also. We mainly looked at external walls and windows, so vertical faces. As for the first one, we looked at what the effect of heightened level of detail would be. We saw that because the buildings, how they were, so the main facades had details, but the endings of the buildings were pretty much the same for the level of detail 3 and the level of detail 2. So the main effect was seen when the main facades where there was the most difference were facing east and west and got the most sun. And then we compared the different levels of surroundings. And so we can see that the main effect is of course seen on lower floors because the population of the area wasn't that dense, so the shadows didn't make it to higher floors. But the main effect was just seen from surrounding buildings, and then additional effect from the trees also. But what are the limitations? Well, first of all, we are relying on standardized solutions and designs, which thankfully in Estonia we have many of those buildings, but it still limits us. Of course, this was a very preliminary study, so we didn't compare it to actual data, and it was not that densely populated, so maybe the effect would be better seen on more populated areas. So we want to examine the impact of trees as shading objects more, because currently we use the same level of sunlight coming through the trees for everything, but we want to make that more precise in the future. We want to validate with measured data, and what I'm really interested in is whether we could apply this for new developments where usually you don't have that much greenery in the beginning, but maybe they are planning to add it. So could we integrate the tree growth prediction to see in the future whether the shading will have an effect or not? So we developed the data aggregation workflow. We did see some difference between scenarios, so we definitely see potential for studying it more. And then as a first step, I think it has started this great potential for ongoing research. Thank you.